Okay, so there's one more part of activity 12-2 we want to work on, which is actually 3 parts. So we're working on this problem involving birth weights, right? So the mean birth weight for babies is 3,300 grams, and the standard deviation is 570 grams, and we're doing lots of work with reading the normal distribution. Okay, so there's 3 more questions we want to pursue. First one is not very hard, but it brings up a good point. Right. Okay, so it asks what proportion of newborns weigh less than 5,500 grams at birth. All right. The remaining two questions are more challenging because they again ask us to do something more sophisticated than we've done before. Okay, asks us to think in reverse a little bit. Okay, so it asks us how little would a baby have to weigh to be among the lightest 2.5% of all newborns? And then how much would a baby have to weigh to be among the heaviest 10% of all newborns? Okay, so let's take these in order. All right, so first let's look at the proportion of newborns that weigh less than 5,500 grams at birth. All right, so I'm going to switch over to my picture, my webcam. Right, okay, so we're talking about 5,500 grams. All right, so look at that. All right, that's off the chart somewhere. It's somewhere up here, right? 5,500. Right. And I want to know what proportion of babies weigh less than that. Well, look, it's pretty much everybody, right? Weighs less than that. All right. So I hope that my answer is pretty close to 100%. All right. Let's run the numbers. All right. So for 5,500 grams, find our z-score. So z is our observation minus the mean over our standard deviation. So it's 5,500 minus 3,300 over 570. And that comes out to be about 3.85, I believe. 3.86 is better. Got to make sure I round properly. Rounded to the nearest hundredth. Okay, and then the probability of getting a z-score less than, I should say probability of getting a weight less than 5,500 is approximately the same as the probability of getting a z-score less than 3.86. Okay, and now I'll go to table 2. All right, and I want to look up 3.86. So I'm on my first page. I'm going to scroll to my second page where I have positive z-scores. Okay. Oh, look it. It is literally off the chart. There is no 3.86. In fact, what it says is if your z-score is bigger than 3.5, it says you can use the number 0.9998. Okay. So, so this is virtually 100%. Right. Okay. So virtually 100% of all babies weigh less than 5,500 grams at birth. That makes sense, right? There aren't going to be very many of them. All right. Okay, so let's go back to our questions. All right. Now we have to be a little more sophisticated. All right, for the second part. It asks how little would a baby have to weigh to be among the lightest 2.5% of all newborns. So in the previous problems, we've been given a weight and asked to find the percentile. Now we're given the percentile and we have to find the weight. So we have to go through our steps in reverse. Do you see? Okay. So let me go back to my picture that I'm oh, I don't want to go that way. I want to go here. Okay. So I want to be in the lowest 2.5%. I don't know where that is. Right? I don't know how many standard deviations. I don't even know where to draw it, right? All I know is that the area has to be pretty small, right? I don't know. I'm just going to draw it here. Okay. So I've just sort of arbitrarily put down a point and said, well, that's about where I could draw the line so that 2.5% of the observations fall below that. Okay. What I really want to do is I want to find the z-score corresponding to 2.5%, and then once I have the z-score, then I can figure out the birth weight. Okay, so given the percentile, let's find our z-score and then use the z-score to find the birth weight. Okay, so how am I going to find that z-score? All right, well, table 2 will work for us. Okay, but we've got to use table 2 in reverse. Do you see? Table 2 gives us area to the left given a z-score. It gives us the proportion, right? We have the proportion, and we're going to use the proportion to find the z-score. Okay, so what I'm going to do is I'm going to hunt in my table until I find 0.025, all right? 2.5%, right? Or as close to it as I can, all right? So here I am. You maybe can't see it too well. You'll have to kind of muddle through it too, and then I'll zoom in when I find it, okay? So 0.025 is what I'm looking for, 0.025, or as close to it as I can get. I'm close. Oh, there it is, right there. Okay, let me zoom in. Okay, no, I'm going to switch screens so you can see something a little clearer. Okay, if we look, okay, it's back on the negative z-scores. 0.25 is showing up right here. So it's corresponding to a z-score of negative 1.9, 0, 1, 2, 3, 4, 5, 6. Negative 1.96. All right? And that's key. Back out here. Okay. So z is going to be approximately negative 1.96. In other words, to be in the 2.5 percentile, to be in the lowest 2.5%, you would have to have your z-score be negative 1.96, or to be 1.96 standard deviations below the mean or more, right? Okay, so now we just have to convert that to a weight, okay? And you can think of this algebraically. So I don't know the observation, right? So I know the observation minus the mean over my standard deviation is negative 1.96, and I'm trying to find x, right? So if you're reasonable in algebra, that's not so bad. Okay, or you can just think about it in your head, right? If you're 1.96 standard deviations below the mean, what you can do is multiply 1.96 by your standard deviation. Okay, and that'll tell you how far you are below the mean. And then just subtract that from the mean, okay? Or in other words, adding 3,300 to both sides, x will be 3,300 minus 1.96 times 570. And we get a weight of, I can pull this off my calculator, about 2,183 grams. Okay? So said differently, if you're 2,183 grams or less, then you are in the lowest 2.5% of all babies in terms of birth weight. Okay? All right, last question, and then we're finally done with activity 12-2. Okay, the question asks, how much would a baby have to weigh to be among the heaviest 10% of all newborns? Okay, so similar scenario, except now we're making it one step more complicated. We're looking at the heaviest 10%, but it literally is one step more complicated, and then everything else is the same. Okay, so how much would a baby have to weigh to be among the heaviest 10% of all newborns? All right, back to our sheet. Okay, heaviest 10% now. All right, so I don't know, again, where to draw the line. Maybe it's here. I don't know, I'm just guessing. but I want to draw the line. It's arbitrary. It's just a guess. It's not correct. I want to find that line so that 10% of the observations are above that line, right? Okay? And then what that means, right? The thing that makes it just a tiny bit more complicated, but not much, is that table 2 gives area to the left, so I'm not going to look up 10% in there. What I'm going to look up is 90%, right? I want to find the z-score that corresponds to 90% in table 2. Okay, so back to table 2. All right, and I'm definitely above the mean, so I got to go to the positive part of the table, and I'm looking for 90%. Sorry about that. I don't know why it's doing that. There we go. Looking for 90% or as close to it as I can get. Okay, I'm close. 1.3. Aha. 1.29 gives me 0.9015, but 0.8997 is closer. So that's 1.28, I believe. 1.20, 1, 2, 3, 4, 5, 6, 7, 8. Right. So the z-score I'm going to use is 1.28. Okay? All right. So back to my other camera. So z equals, or at least approximately equal to 1.28 corresponds to the 90th percentile. Right? And then again, it's just a matter of algebra, right? I know the observation minus the mean over my standard deviation is 1.28. Fill in the details. I don't know what the observation is. I'll call that x. Minus 3,300 over 570 equals 1.28. Multiply both sides by 570. And then add 3,300 to both sides. So x is 3,300 plus 570 times 1.28. Work that out, and we get just about 4,000, well, I get 4,029.6 grams, or if I want to round, 4,030 grams. Okay? So if you want to be in the top 10% of all babies, which I was, by the way, I was a very fat baby when I was born, have to be more than 4,030 grams. Okay? And that finishes activity 12-2. Please let me know if you have questions.